Hello students, this is the Digital Knowledge Irshad Academy uploading a new video for stage binary ripple counter Synchronous, and of course it is up counter which counts from 0 to 15. Before going to circuit operation, do not forget to subscribe my channel and press the bell icon so that fresh video reaches you routinely. Looking at the diagram is very similar to asynchronous counter. 4 flip-flops A, B, C, D connected, but there are 2 changes made. In previous flip-flop, that is asynchronous, JK terminals of each flip-flop, they were connected to logic 1 voltage, but in this case JK terminal of first flip-flop is connected to logic 1 voltage, and the other JK terminals, they receive the output from the previous flip-flops. In case of asynchronous, the subsequent flip-flop was waiting for the previous flip-flop to change the state. That is to say, B was waiting for A to change the state, C was waiting for B to change the state, D was waiting for C to change the output state. But in this case, clock pulses are simultaneously applied to all flip-flops. But in case of asynchronous, clock pulse was only applied to first flip-flop. Now going to the operation, pulses that we want to count are coming from square wave generator and applied at the seek input of all flip-flops. With the first pulse falling, QA toggles, the output rises from 0 to 1, and it is here 1 0 0 0, or if you have connected lamps, QA will light, B, C, D they will remain off. Second clock pulse falling, this is going to toggle from 1 to 0, and clock pulse is already applied. This time this is going to toggle and the output rises from 0 to 1, and now we have QA 0, B is 1, C 0, D 0. Third clock pulse, QA toggles to 1, B is 1, and C, D they are 0 0. This is QA will light, B will light, and this is BCD of decimal 3. Fourth pulse falling, QC will toggle, the output will rise, QA, QB, QD will remain off. Fifth clock pulse, QA and C will light, B and D will remain off. Sixth clock pulse, QC, QB output will be 1 1, A and D will remain 0 0. Seventh clock pulse, all the 3 first flip-flops A, B, C, their outputs will be 1 1 1, D will be 0, and on 8th pulse they will toggle back to 0. This is 0, this is 0, but D will toggle and the output will rise from 0 to 1, and it will be 0 0 0 0 and 1. This is nothing but BCD 8 of 8th pulse. For 9th pulse falling, A and D output will be 1. For 10th pulse, D and B output will be 1. For 15 pulse, QA QB, QC, QD outputs will be 1, 1, 1, 1, or if you have connected lamps, this is going to glow, A will glow, B, C, D, they will glow. On 16th pulse falling, all the flip-flop will reset to 0. This will fall to 0, QC will fall to 0, D will fall to 0, and they will reset to count 0, 0, 0, and the count will start again. That means after every 16 clock pulse, the flip-flop will reset and the count will start again. Now, point to note here is that QA toggles for every clock pulse. That means it will toggle 16 times and provide us 8 pulses in the output. B will toggle after every 2 pulses, that is 2, 4, 6, 8, 10, 12, 14, 16, means it will toggle 8 times and provide us 4 pulses in the output. QC will toggle after every 4 pulses and provides us 2 pulses in the output, that is 4th pulse, 8, 12, 16, 16th pulse. It will toggle 4 times and provide us 2 pulses in the output. D will toggle after every 8 pulses. That means it will toggle when the 8th pulse falls to 0. The output will be 1 and will remain 1 till 16th pulse falls, and it will toggle 2 times and provide us 1 output. Looking here on this AND gate, see that QA with green color, QB with green color is 1, 1 only with the 3rd clock pulse, and this one goes to AND gate 1. Here QA is 1, B is 1 on the 4th rise pulse. When the 4th pulse falls, this is going to toggle and the output will rise from 0 to 1. This one is also coming to AND gate 2. Now all the 3 inputs, QA is 1, B is 1, C is 1 with green color, QA is 1, QB is 1, QC is 1 going to NAND gate 2, and the output of NAND gate is 1. This one is applied at the JK terminal of D flip-flop, and on 8th pulse this is going to toggle from 0 to 1. The output will be rise from 0 to 1. Now since all the flip-flops toggle simultaneously, and this problem which we were facing of propagation delay, that has been overcome, and there is no question of waiting for A to change the state, C waiting for B to change the state. Now coming to the summary of flip-flops. Summary is: clock pulses are applied simultaneously to all flip-flops. In asynchronous, clock pulse was only applied to first flip-flop only. JK terminal of FFA is held at 1. In case of asynchronous, all the 4 JK terminals were connected to logic 1 voltage for toggling mode, but in this case only the JK terminal of first flip-flop is tied to logic 1 voltage. Output of FFA taken from QA goes to JK terminal of FFB and AND gate 1. FFA toggles with each clock pulse. FFB complements if FFA is 1. FFC complements if FFA is 1 and FFB is 1. FFD will complement or will toggle or will change the state when all the previous flip-flops, that is FFA is 1, FFB is 1, FFC is 1, that is already explained. And now with the 8th pulse, this is going to toggle and provide us the output FFD. At falling edge of 16 pulse, all flip-flops are cleared to 0 and the count starts again. 16th pulse is responsible for resetting the counter to 000. Since all flip-flops toggle at the same time and with the same clock pulse, propagation delay is minimized, and we were facing this crucial problem that it had set a frequency limit. Why? Because the propagation delay was large. The subsequent flip-flop was waiting for the previous flip-flop to change the state, but in this case all flip-flops are clocked simultaneously and they work together and there is no waiting. As such, the problem is minimized. That's all. Thank you very much.